Welcome to the CSK8 podcast. My name is Jared O'Leary. In this episode, I'm going to interview Eljakim from the Bebras Challenge and the IOI, which stands for the International Olympiad in Informatics. Since this is my first interview episode, I kind of want to give some background on what to expect. A typical interview will begin with myself asking the guest to introduce themselves. Now, the reason why is because I want the guest to have control over their own narrative in terms of what is said or not said in their bios. Next, I will ask some questions about their background or some context questions so we can better understand their experiences in computer science education, and then we'll get into some more topical questions related to the guest's expertise or things they'd like to share with everyone. And finally, most interviews will close with some open-ended questions for the field or some wonderments that the guest might have. In this interview, I will ask him about his background in education. I will then talk to him about the Bebras Challenge, which is a challenge that CSK8 educators could use in a couple of weeks, starting in November, or as a pre-test and post-test throughout the year to kind of better understand kids' understandings of computational thinking. And then we will talk about the IOI, which is the International Olympiad in Informatics. Now, the IOI is basically like a programming competition for the elite programmers out there. So if you've got some kids who are really good at coding, then you might want to point them towards the IOI to learn some more, or towards the American version, which we will discuss in the interview itself. I really hope you enjoyed this interview. I had a wonderful time with Kim, and I'm going to start this interview with Kim introducing himself.
My name is Eljakim Schrijvers, and my friends just call me Kim. And I run the Bebras Challenge in many countries, and I'm the treasurer at the International Olympiad in Informatics. And I'm also the coach of the Dutch team for the IOI, which is that International Olympiad. And at the IOI, I actually run the live broadcast where I talk to thousands of people about programming.
Now, can you tell me the story of how you got into computer science and informatics education?
Yeah, you have to remember that I'm an old person. I'm 45. And so in my elementary school, nobody had a computer. And then my dad was the first person in the street to get a computer. And our television was still black and white at that time, just so, for reference. And so I was on the computer every night, learning how to program, doing things. I taught myself concepts like a stack and recursion. And so I'd never learned these things from books. And then by the end of high school, all of a sudden I learned of the IOI, I got involved, and I started training the Dutch team once I got to university. And so I studied computer science in the Netherlands. And to be really honest, I absolutely hated it from day one. Because when I went to their day, their open day, where they tell you about your studies, they promised me, Kim, if you come study here, remember, it's not all about programming. You will not spend your whole day behind a computer. You will learn so much more. And I was like, oh, cool, that's what I want. The first couple of weeks, they taught me how to use VI, how to use the Unix command line. And we were programming, and we were never gone from the computer screen. And this was back in 92. So I was like, this sucks. This is all about computers. I want to learn more.
Right.
And so I went to the counselor and said, I'm just going to go. This is not really my thing. The counselor was like, well, you can't really do that because you're the best kid we have right now. And we're just going to keep you. And then so I just, stayed, and it got more fun because we spent less time behind the computer and more time thinking about algorithms and, nice, cool stuff, the things that I like doing. And then after 4 years, I just graduated, got my master's degree, and started a computer company.
During your time, it sounds like you had a lot of informal education, just kind of experimenting on your own and tinkering on your own computer before you went into the formalized computer science education?
Yes. We did not have any computer science education in schools at the time.
Mm-hmm.
So my high school was from 1986 till 1992. The internet wasn't really there. I used BBS's, bulletin boards.
Right.
Where you dial up with the modem. And I would play Trade Wars with my friends, which is a character-based game where you just go around the globe. Those were the days. We used Turbo Pascal and Turbo C, Quick Basic. That's how I started.
In the US, there are a lot of teachers who don't have a background in computer science and who are basically being asked to teach a subject area that, one, they've never seen taught before, and two, they've never actually had experience with. So since it sounds like a lot of your education was informal, what would you recommend in terms of like learning how to teach yourself computer science or programming?
What I find important, I want these teachers to realize it's okay if your kid is better than you are. It's great if you have a student that's smarter than you are. And I always give as example the math teachers. If in math class they find a prodigy, if there's this kid in math that's brilliant, you know what math teachers do? They call up their classmates from their own university, and they go like, "Oh, I have this kid and he's great, and oh, maybe he will just win a prize, and let's send him to the Olympiads, and let's give him this and let's give him that." And then they give that teacher the feedback. What should I do with this kid that's smarter than the teacher?
Yeah, the nice thing is there are some organizations that are helping with making those connections with computer science professionals. So teachers in the US can like contact co.org, and they often will be able to find a local computer scientist who can like come in and help mentor or
Right.
provide feedback and whatnot.
And that's exactly what I'm trying to do.
Cool.
You have also coder dojos all across the US. I'm in fact helping out with the coder dojo here in the Netherlands at the local library, where we're helping a lot of elementary school kids, and we teach them the basics of programming. And we actually try to make it what we call an organized chaos. So there's no classroom, there's no teaching. We just have loads of tasks for the kids to do. We give them the tasks to work on, and then we have enough volunteers to help them when they get stuck, but also to give them more tasks if they're done. We had a girl the other day that was really good and really fast, and she kept coming to me and saying, "I'm done, I'm done, I'm done." Because once you're done at our coder dojo, you're allowed to print something on the 3D printer. So she really wanted to go to the 3D printer. And I'm like, "But you're so good. Let's make this problem even harder for you." And she'd written some interactive story using Scratch. And I said, well, the singer obviously has to wiggle while singing. So she had to figure out, how do I make it turn back and forth, and how do I make that work well?
Right.
And she solved it all. And so that's the kind of tinkering that I enjoy doing, and that I think that kids that want to get good at this should do as well.
Yeah, I think that's a safe way for computer science educators who might not be comfortable with like programming in particular, is just ask questions that kind of get kids to think deeper about what else could I do? How could I add more to this? And even if all you can do is come up with the ideas, but you don't know how to code it, that's okay. You can still guide through some questioning techniques, and you'll eventually learn how to do it.
I'm all in favor of having teachers know, realize, and inform the kids that, yes, they're there to help, but no, they don't know everything. But fortunately, there's the internet, and the teacher can provide guidance on where to find things and which materials to use. Even though the teacher may not know every answer immediately, the teacher can help out with these things.
Yeah, I think that's a great strategy. That's something that I tried to use as well. There were a couple times that kids would ask how to do something in a programming language, and I'd be like, I don't know how to do that yet. Let me find out. I'll do some research, and I'll chat with you tomorrow about it.
And there's the thing, right? The key word that you just used is, I don't know how to do that yet, which is much more positive than I don't know how to do that.
Yeah.
No, but that's the key thing, right? Today with the internet and with continuous education and everything that's going so fast, working in sprints in companies. Why don't we work in sprints in schools? Why don't we just say, well, I don't know how to do that yet, but I'll know next week.
Yeah, and one of the things I try to highlight with kids when I would go through that process, I'd come back the following day and say, here are the strategies I tried to apply to figure this out, and here's how long it took me. So the reason why I did it overnight is because it ended up taking me an hour to find the correct solution.
Yes.
But I found all these other like partial solutions along the way, and then I finally got to it.
Right.
So like the idea was to get them to think through the process, not just to give them the answer.
And that's really, really important, obviously. One of the things that I do is the Bebras challenge, and there I try to motivate the kids to learn more about computational thinking. So yes, it's a challenge. And in some states, we even have a second round for the best kids. And they get to go to a university and they get a whole day of more fun computer science. But my goal is to reach every kid in America.
What is the Bebras challenge? Like, how would you describe what it is to somebody?
The Bebras challenge is basically 45 minutes of fun puzzles, logical thinking things, algorithms, a little bit of data structures. And the tasks are set up from easy to hard so that it's fun for everybody. So if you start with it, you're not expected to finish. If you finish, it's great. But if you don't, you still have had a good time solving the task that you were working on. Once you hear the explanation of the solution, you are going to understand it. And you're going to be like, oh man, I wish I would have come up with that. That's so nice and simple. Oh, that is so cool. What a great way to do it. And for me, a good task doesn't have to be overly hard. A good task is something that you can think about. You should be able to come to a solution by yourself. And the only thing limiting you during the challenge was that there was a 45-minute time limit. Oh boy, I wanted to have another 45 minutes. I would have solved them all. One of my test subjects is my mother. And my mother is a retired 75-year-old French teacher. And she likes to work on the puzzles. She thinks about them. And she comes up with solutions. She managed to solve them all. And sometimes I'm surprised. I'm like, Mom, how did you solve this? She's like, well, I just wrote out every possible solution. I'm like, that's 15 pages. She's like, no, it's actually 20 pages. and I was like, well, how did you do that? She's like, well, I'm retired. I have a little bit more time than you do. And then, so she comes up with the correct answer. And then I tell her, well, there's actually a smarter way of doing it. And that's this and that. And then she's like, oh, that's clever. And then she realizes that. And then the next year I give her a similar task. And then she applies this methodology that I have taught her without her realizing that I was teaching her something.
So what's an example of like an easy challenge that a kid might work on?
So here is a non-visual task. There is an inspector in a city, and the city has a museum. And in that museum, they have a diamond. It's called the blue diamond. And the reason they call it the blue diamond is because it's blue. During the day, 2,000 people have gone to the museum to look at the diamond. And at the end of the day, as they close the museum, the janitor closes everything, sweeps the floor, and he's like, oh, that's weird. The blue diamond is green. And so someone during the day has taken the blue diamond and replaced it by a green diamond. So they call the inspector, and the inspector comes to the museum, and he says, well, who could have stolen it? The museum says, well, we had 2,000 people that came through the museum today. We know exactly in what order they have come through the museum. We scanned their tickets, so we know exactly in which order they came through the museum. And so the inspector is going to go to these 2,000 people, and he will ask them, when you looked at the diamond, what color was it? Was it blue or green? And now the question is, how many people does the inspector have to interview in order to guarantee that he knows for certain who is the thief? To make it a little easier and to make sure that there's no off by one errors, because this is not about how good you are at math. It's multiple choice. And so the answers are A, you have to speak to all 2,000 people. B, you have to speak to at least half of them. But if you're not lucky, maybe, 1,500. Answer 3 is you have to speak to at least 100 people. Answer 4 is, well, don't know exactly how many, but definitely less than 20 if you do it in a smart way. So you understand the problem, right?
Yeah.
Now, let's, you and me, play a little game. The game is called Guess a Number. I'm going to think of a number between 0 and 2,000. See how clever I chose these boundaries to match up with how many people went to the museum?
Yep.
I'm going to have a number, and you have to guess it. And you can guess a number, and I will say higher or lower, or hey, you're correct. Right? So what would your first guess be?
1,000.
Exactly. You would guess in the middle. Because, if that's the number, then, gee, you're lucky. But obviously, I'm just cheating you because I will just try to make this game last. So I'm going to say lower. What would you guess?
So 500.
500. Lower.
250.
Lower.
125.
And you see where I'm going?
Yeah.
You keep halving how many possibilities there are. So when there's 125 and I say higher, the number has to be between 126 and 249. Every time you ask me a question, if you ask the right question, you can discard half the numbers. And boy, does it go down fast that way. And if you were asking less smart questions, if you would ask one and I would say higher, and then you'd say two, higher, three, high. Do you see where I'm going? 2,000 questions. But the way you did it, the clever way, you start halving the thing. And we call that a binary search. It's just a computational thinking concept. It's an algorithm.
Right, but kids don't know that they're actually engaging in that when solving the problem.
Right. At some point, the diamond changed from green to blue, or from blue to green. And that point is basically the number that we're aiming for. If someone says blue, they mean higher. And if someone says green as answer, they mean lower.
Right.
It's the exact same problem, just, in a more accessible way, a bit more clever maybe, but it's a fun little thing. And we tell this to the kids, and most kids actually figure this out. But then when you talk about it and you give them this explanation, and they're like, oh, that's pretty clever actually. And then once they start really thinking about it, because sometimes they say 100 guesses, even though they figured this out, then they start thinking about it, how fast binary numbers go up when you keep doubling everything.
Right.
And because we don't really we don't care if the answer is 11 or 12, or maybe even 13 if you're off by one. We don't care about that. That's why the correct answer is definitely less than 20, so that in your mind you don't have to calculate everything. You just think about it a little bit.
So if a kid were to do a challenge like this with Bebras, what kind of feedback would they get to help them understand how to think computationally? So if they got it wrong, if they were going through like randomly, like I'm going to pick 7 and then 500 and then 14, like, how would you help them understand there's a more efficient way to sort through things?
So in this case, this specific problem we've used was just multiple choice. Mm-hmm. So we were not playing against the kid. So it really was just, pick A, B, C, or D.
Right.
And we don't tell them immediately if their answer was right or wrong.
Mm-hmm.
But once the contest is over, we have a coordinator's manual that we send to all the teachers with every question in it, the solution, and background information. So here you can find more information. Why is this informatics? That's what we call it. We call the section "It's Informatics," and then we write down why we think it's informatics, which URLs can you go to find more information about it, and stuff like that.
Excellent. And so are the questions categorized into different computational thinking and informatics categories? And so, I noticed the kids didn't do really well on this particular category, but they did great on this one, so I should review X, Y, and Z.
So we have the domains: algorithm and programming, data structures and representation, communication and networking, computer processes and hardware, and interaction systems and society.
Yeah, that sounds like it hits a lot of the categories in the national standards from CSTA.
Right. So these domains, they are not exactly aligned to every country, because I do this in many countries.
Yeah.
But it aligns 90% to whatever is happening in every country.
Right.
And so we sometimes change it around a little bit. But so this was an algorithm, right? This is binary search. When it comes to communication and networking, we have tasks where we give the kids a black and white image. So pixels, say a grid of 8 by 8 pixels. And we tell them, when you're communicating stuff, sometimes the other side doesn't hear every pixel correctly. In order to come up with a clever way to fix this, computer scientists quite often put in what they call a parity check. So at the end of every row, we put one extra pixel to make sure that the number of black pixels in that row is even. At the bottom of every column, we also put in a black pixel to make sure that the total number of black pixels in that column is even. So if in a row there are 5 black pixels, you would put in an extra pixel in that extra row. But if the number of pixels that is black is 4, then you put in a white pixel in that extra pixel at the end of the row. Similarly for the vertical ones, for the columns. We explain to them that this is an error detecting code, and then we give them the image that has a mistake in it. And we ask them, what is the transmission error? So, they have to choose from 64 bits and figure out which one is the wrong one. And in order to do that, you don't really have to count, but you have to see, okay, which row does have an odd number of black pixels because that row has an error, and which column has an odd number of black pixels, and where they touch each other at that intersection, that's the wrong pixel. So it's either a black pixel that should have been white or a white pixel that should have been black.
Yeah, and I love that if kids were to not get that correct, then you provide supporting materials that kind of help facilitator guide them through that process to understand.
Exactly. And we give them more information, not during the contest, but afterwards in those materials. We talk about, well, this is an error detecting code, but it can only detect one error because two errors could cancel each other out. And there are also error correcting codes. But for an error correcting code, you need much more extra bits to hand out. Then sometimes we get the question, well, why would you use an error correcting code when you can just detect it and then have it sent to you again? And, internet is so fast. And then we explain, but we're sending missions to, Mars, to other planets, where it takes 7 minutes for a message to get there. And then 7 minutes to get back the information that something has gone wrong. And then another 7 minutes to send it again. So it can take 21 minutes then before you've resent some information. So in that case, you want that error correcting code.
And what are the age ranges or groups that are for the Bebras?
We start with kids that are 6 years old. So we have our age ranges usually in 2-year ranges. So there's 6 to 8, 8 to 10, 10 to 12, 12 to 14, 14 to 16, and 16 to 18.
And so they all scale for the age range, like the difficulties and whatnot?
Yeah. Every age range gets their own set of questions.
Excellent.
And sometimes, we're computer scientists, right? So we're lazy by definition. So sometimes we reuse tasks. So we can use a task for the 10-year-olds, and then for them we say it's a hard task. And then we use it again for the 12-year-olds, and there we say it's a medium hard task. And then for the 16-year-olds, we just use it as one of the easy tasks to warm up with.
Yeah, I don't know if that's lazy as much as it is efficient, but I hear what you're saying.
Yeah, you bring that a lot more positive, but
I try.
I think it's lazy.
And what do you want teachers to know about how they could potentially use Bebras? Is this an online thing? Could they do it pencil and paper, or how would they use this in a class?
The beauty here is that it's completely online. We have a 2-week period coming up soon, actually, begin in November, the first 2 weeks of November. They can just do it online. The kids need 45 minutes, but they can take any point in time during these 2 weeks. So we have a lot of school districts where actually every school takes part and every class has to take part and all the kids have to take part. And the fun thing is that the kids love doing it. So that's really nice. The teacher does not have to prepare very much because he just tells us, I have so many kids. And then we will send him a page with accounts that he can use for the kids. And it works itself. And then afterwards, we send him the materials. And a lot of schools then use those materials if they have a specific teacher for this. They say, well, there were 15 tasks, and we're going to be spending 10 weeks on these 15 tasks. So 10 class hours, just diving deeper into it, finding extra materials, thinking more about it, stuff like that.
How else could kids practice this? I noticed there was an app on the website.
So we have an app with 100 tasks that you can just download on iOS or on Android. And there are 100 fun puzzles in there that you can just do and have fun with doing. And it's not just children. We really try to stimulate people to do this together. And so my in-laws, enjoy doing it. So they sat down together in front of a fireplace. This is North Dakota, so it's cold. And they use the app and they spend multiple hours just trying to solve the problems and trying to come up with, okay, why is this not working? Or is there a smarter way of doing this?
Yeah, I think the app would be an interesting way to keep kids engaged if they finish a project. And let's say they finish a project that's supposed to take 2 weeks, they do it in a week. Well, they could go through these challenges during that time if you don't want them to get too far ahead.
Right. But we have more. We have, now I sound like one of those old TV commercials, but wait, there's more. This vacuum cleaner does not only clean the floors, you can use it on the ceiling. No, but so there's more actually. We have a quiz software where a teacher can create his own quizzes from the tasks that we have in the system. And so we actually have some predefined tasks that we suggest to them, but they can just mix and match and say, okay, I'm just going to set a quiz for my kids. I'm just going to be using this, and the teacher can click on grade, and the system will grade it, and the teacher can download the results as well. So I have a bunch of schools that I know do something like this at the beginning of the school year, and then at the end of the school year, just to see where their kids are, and they use it as an aptitude test.
Yep.
I like that. I enjoy that. But my Bebras challenge in November is what I call a motivational aptitude test. I had a school where the science department was completely stressed out and overworked, but the language department said, "Oh, we can just do it. I mean, we'll just use one of our English lessons and we'll do it, and no problem." And then they found some kids that had been told by their parents, "You're not good at this. Girls can't do this. Go for languages." And there were a couple of kids that they found there that were really, really good at it, and then switched into more mathematical and computer science topics just because they found out that they liked it and they were good at it. In most countries, we're very good at measuring how well kids perform at sports, how well they perform at languages, how well they perform at mathematics, but nobody measures how well they perform at critical thinking, computational thinking, logical thinking. The keyword there is thinking.
Right.
We don't measure that.
And so speaking of the measurements, and you mentioned like a pre-test, post-test kind of scenario, how are researchers using the Bebras?
I delete all the data at the end of the competition half a year later, because I just don't want any privacy rules to be changed.
Right.
So we're not like Facebook where we store everything. I do have all the results from the past years without the kids' data. So I know the age range of the kid, I know the state, and I know their gender.
Okay.
And that is already controversial because I have researchers contact me saying that they want me to ask race and self-identified race and gender, self-identified gender, gender at birth,
right?
Racial subgroup, skin color of your friends. And
right.
But you're laughing. But to me, that's completely ridiculous. My goal is to reach everybody, and I don't care.
Yeah, I understand where the researchers are coming from with wanting that information. It might be helpful for their research interests, but they could engage in the Bebras on their own and collect that kind of information. But I understand why you're removing those kind of identifiers from it.
Right. So when it comes to Bebras, we promise the teachers, and this is very important, we promise them that the results of the kids from their school will never, ever be shared with other schools. So no matter if your kids do poorly or well, no other school will know. Having said that, we will show you a graph of how well your school performs compared to all the other schools in your state and to all the other schools in the nation. So the teachers can see if they're doing better or worse. And I see here as well the funny thing that they go to their principal, or the principal goes to the school district, or sometimes to the governor to say, look, we need more money because we're not performing as well. Or they go and they say, look, it works that you give us money. See, we're the best. We need more money because we want to stay the best. But so these things, I think this is important. I think it's important if you're as enthusiastic about these things as I am, that you want to try every venue to get the resources. So that's the teachers, but also the money and also the students, to get everything together to create an environment that's stimulating and motivating for all the kids.
That chart, does it break it down into the subcategories, or is it just overall your kids did this, the nation did this?
Last year, it was only overall. But this year, we are showing the teachers a spider graph. I don't know if you know what that is.
I don't think so.
It's a little chart that looks like a spider web. And then on every side of the spider web is one of those dimensions.
Okay.
And we show how well your kids did and how well the nation did and how well the state did. So we will show you per domain how well you're doing as your whole age group.
Excellent.
And then we also show you your class list if you're interested, where you see the names of your students below each other. And then you see the 5 domains as the columns. And then a color that indicates how well everybody did. So then you will see the excellent performers are horizontal green lines,
Mhm.
and the domains that you're good at are vertical green lines, and the weaknesses are less green.
Yeah, I think that'd be really helpful to get that kind of feedback because I know a lot of computer science educators, they tend to feel isolated. They might be the only person in their school or sometimes even in their district that's doing this, so they don't know how their kids are doing
Right.
comparatively. So this would be good information to have.
And another thing that's interesting to know is I do this as well in the United Kingdom,
Hmm.
and they have some good universities there. And I don't know if you've heard of Oxford University.
Yeah, I think I've heard of that before.
Okay, at Oxford, they say that if you've made it to the finals of the Bebras in the UK, they want you to put that on your application
Huh.
because your odds of getting in are higher. And I've heard similar things about certain universities in the US where they say, well, kids should really put it in there, on there. If they're a high achiever at this and they want to go to one of these big universities, put it in there. And that's why I also focus on, the Carolinas and Georgia with Clemson, because it's a good area, they're friendly people, but they're not your logical choice. If you're looking for computer scientists, then you would go to the Bay Area, California. We do another second round in Erie, Pennsylvania.
Hmm.
That's on the, well, I wouldn't call it the Canadian border, but you can look at Canada from where they're located, and there's nothing around. What we do for multiple states around there, and the kids come there, and they sometimes drive 12 hours one way
Wow.
to come to the finals and to see me speak and to get all the activities that the university organizes during that day. And they're just having a good time. And then they say, thank you, thank you, thank you for this. And they come back. It's great.
So if the Bebras is done online, why the in-person second challenge?
The second round,
Yeah.
yeah, well, I do think it helps to for those kids to actually see that thinking can be a sport as well. There are plenty of people that play recreational tennis
Hmm.
or golf, and you will never ever see them on Wimbledon
Right.
or on a Masters tournament, and nobody cares about that. Why is that not the same way for thinking? Why can't we have these things be fun
Yeah.
and have different leagues and just go there? And some of these kids that show up have never been to a tournament. They come to this online, they're excited about it, they're nervous. So the first thing we do, we welcome, welcome, welcome. We give them some food. We put them into the room where they work on the tasks. And while the kids are working on the tasks, I personally talk to the parents and teachers, and I give them the background information on the problems that the kids are working on at that point.
Hmm.
So that during that 10-hour car ride home, they have something to talk about.
Interesting. That's a really neat idea.
Well, otherwise, what are you going to do? You tell the parents, no, 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 but you're laughing, but you tell the parents to drive for 10 hours and then you leave them alone, sit in a corner with a book while we do something fun with their kids. Well, why don't we engage the parents as well? Because I really find when it comes to computational thinking, this comes back in your life all the time. Even when driving to the university or driving home, usually there are multiple routes. So you're trying to optimize something, but how do you optimize? And then you get into the whole thing where, the real hardcore computer geeks think that they know best because they have the algorithm that knows best. But you may want to drive a different route because you like the scenery better,
Right.
or because there are fewer traffic jams. All these things are valid arguments when evaluating an algorithm.
Right.
So I tell this to the parents, and I tell them, why don't you talk about these things with your kids all the time? Bring it into the home curriculum as well. Why are we doing this? Why are we doing it this way?
So the resources that are shared with the teachers, are those also shared with parents? Like, do they have that opportunity to look at the after the tests are done or the challenges are done, they get the supplemental resources that explain things?
Well, not after the first round. We send those
Okay.
resources only to the teachers.
Okay.
So we try to get the schools engaged.
Yeah.
And in order to participate, you have to go through the school, and there's a teacher that actually arranges it. But after the second round, we share stuff with the parents, and sometimes they send me email messages afterwards, and I just respond to that because I just love doing this.
Yeah, I think that's a really good strategy. And I think teachers who do the first round of it, I think it would be good for them to also reach out to parents and potentially even share, like, here's what we did in class today. And then if you want to learn more, maybe you can check out X, Y, and Z so you can talk with your kids about it, just to further encourage that learning.
Right. And the thing here that's funny and actually sad is that, so I run this as a volunteer, right?
Mm-hmm.
And so there's no money involved. This is just, I run a company as well where I try to make my money. And this is, 40 days per year that are just my volunteering contribution. And nobody wants to sponsor it because everybody says there's a problem in the workforce. We don't have enough computer scientists. We don't have enough thinkers. And then I say, but I'm reaching out to all these kids that are 8 to 12, 14. And they're like, yeah, but they won't come into the workforce until 10 years from now. And we can't wait that long. And all I keep saying is, if you'd listened to me 6 years ago, you got to start at some point.
Right.
And this is why I engage the parents as well and the teachers as well, because I find that if you can convince the parents and teachers that this is fun, and you can convince them, well, the kid is still under 12, they will still have a positive influence and the kids will still listen. It makes no sense to convince a parent of a 17-year-old because that 17-year-old has already made up their mind and no longer listens to the parents. Whereas but the younger ones still listen and the younger ones still pick that up. So I think I want to motivate the kids, but I think part of that is also just getting the parents enthusiastic.
Yeah, I think that's a great mission, and I applaud you for that.
Well, thank you.
Of course. What is IOI?
So can I compare it to Bebras a little bit?
Yeah, please do.
Okay. So Bebras is aimed at everybody. Bebras is aimed at the top 99% of the kids. So there's always the bottom 1% where, this is too hard. This doesn't work. If you can't read or, there's no way to do this. Although we do have stuff for blind people as well.
That's great.
But IOI is at the other end of the spectrum. IOI is about computer programming, algorithmic programming specifically. It's aimed at the top 1% of the population and maybe the top 0.001% of the population. It's really, really hard. But it's about programming. It's about algorithms. In IOI, every program is, there's a little story. And then basically the question is, read some ridiculously large set of data from somewhere and tell us something about that data. Here is a graph of a country. Tell us what is the shortest path from A to B. That would be a trivial problem at the IOI level. But it's programming. And because it's aimed at older kids and it's so much abstract, yet so much easier to judge, it has an international final. So in the US, there's the United States Computing Olympiad, the USACO, which is organized by my friend Brian Dean. And so he's a professor in the US. He arranges the US team. I am the coach of the Dutch team. So I do the Netherlands. And then every year we meet in summer in some random country where we bring all the students and they get together for 1 week, and 2 days of that week are about computer programming. These problems are really hard, and it's not a spectator sport. So you have 5 hours to solve 3 problems. So you're looking at 200, 300 children sitting still behind the computer for 5 hours. And then at the end, we pick a winner. I explained it once to my wife by saying, yeah, it's like, you're watching a brick wall for 5 hours. And at the end, someone decides which brick is best.
Sounds riveting.
Yeah, but the rounds that come before that are extremely fun, and you can learn a lot. The USACO has 2 rounds. So the 2 groups, the bronze group and the silvers and then the golds. And you can move from league to league. If you do really well in one league, you move to a higher league. Mm-hmm. Within the league, you just learn a lot and the tasks are more at your level. And that's one thing that you have in athletics as well. But that's also what's fun to have in computer science. If I give you a problem that is so hard that it feels like I'm hitting you with a brick on your nose, you get disappointed pretty fast.
Right.
But if I give you a problem that feels like I'm throwing a pillow at your nose and you just have to dodge it, then you may not be able to dodge it every time because you're not fast enough, but it doesn't hurt as much. And by the time your reflexes get better, you're like, yeah, bring out the brakes, Kim.
Just wear a helmet. Stay safe.
Oh, wear a helmet. Yeah, wear a helmet. Sure, this curling parents. You don't have that term in the U.S.
The curling, the sport?
Yeah, but the curling parents.
No. What's that?
Oh, curling parents. That's a term in Europe where you have parents that will never ever let their kids fall or suffer or get hurt because they always have the little broom and they're in front of the kids
Okay.
trying to make sure everything goes as smooth as possible for that child and they end up exactly where they should end up.
You know what? I think that is a very appropriate term that I think some people in the U.S. should probably try and adopt. I've seen some parents like that.
No, but so IOI is fun. It's a nice community. And once you meet all these kids that make it to IOI, they're so much fun, but they're also so much in their element. Because some of these top performers, they've been yeah, geeky their whole life. And to me, geek is a compliment. And nerd is a compliment. These are, I take up all these things probably the wrong way, but I look at them as compliments. And these are my people. I like to hang out with all these kids, and I like to hang out with the teachers that are there, the other coaches. And while we sit there, the night before the competition, the tasks are being brought out, and I'm getting goosebumps just thinking about it. But so the night before the first competition day, we around 8 o'clock, we get the tasks as the leaders. So the quarantine starts, the kids are in a different hotel, we get the tasks, and we look at the tasks and read them, and then people start screaming at each other, just, oh, this is horrible, and how can they do this? Oh, this is clever. And then they sit and we discuss them for 2 hours, and then usually everybody just loves them. And then we translate them. Because this is not a competition about who is the best English speaker. This is a competition about who's the best programmer for algorithmic programs. And just as you would probably agree that would be unfair if we would give German tasks to the US team, it's unfair if you give English tasks to the German team. And I have to explain it this way because quite often in the US, people ask, well, everybody speaks English, right? And if they don't, they should just learn to speak English. And I'm like, yeah, that's not how it works in the rest of the world. So it gets translated. But we do that throughout the night. Some countries are still translating at 4 a.m. And then at 9 o'clock, the contest starts. All the kids get into a big, usually it's a sports venue because it takes up so much space. Sit down, and then the contest gets started. And then it's dead silent for 5 hours in that whole audience hall. And now while that's happening, I run the live broadcast where we show footage from the contest hall. But like I said, that's pretty boring. But then I bring in the people that have made up the tasks, and we discuss the tasks, the background, how should you solve this. But we also bring out the people that look after the kids. So every team gets assigned a team guide. That's usually a local boy or girl that speaks the local language and will help out these kids. And so we bring them out, and I'll ask them, what are the names of your kids? And then they mispronounce the names, obviously. And they're always proud of the students that they have to look after, and they're proud of their country. And I know that this is one of the favorite parts for most of the parents because they had to send their kids to Azerbaijan this year, or Russia, or Singapore, or any of these countries. They send their kids there with random people. And then they love seeing that the people that are there actually look after them.
Yeah, and I will say, having watched some of the broadcasts, it's really interesting seeing you talk with somebody about the thought processes involved of like different ways that you could solve something. So one of the ones that you did for this past summer was talking about ordering pairs of shoes.
Yes.
Make sure that it's always left, right, etc. Uh-huh. And it's starting out of order, and then talking through, well, you could do it this way, but here's another way you could do it. So it was interesting to watch and to learn from that, and just to kind of see those different processes that somebody could take for the same problem.
Exactly. And that's what we do, because remember, the idea of the IOI is, yes, we want to pick a winner, but we'd like to have a ranking where we can rank 320 kids from number 1 to number 320 with as few ties as is possible. Mm-hmm. So whenever we come up with a problem, we try to have it in a way where there are maybe multiple strategies, where one is a great strategy and one is, not as great. And, we'll give you more points for the best strategy.
Right.
And that way we can rank kids.
Yep. And so IOI standing for International Olympiad in Informatics. How would you describe what informatics is to a kid who might not have heard that word before?
Oh, this is unfair because the IOI is called informatics, but it's about a tiny, narrow little corner of the whole field of informatics.
Okay.
So IOI is not at all about informatics. IOI is about algorithms and data structure.
Okay.
Informatics is much wider. Informatics is about computers in society. Informatics is about networks, information security. Yes, data structures and programming and algorithms are part of it, but there's so much more. User interface design is part of informatics as well. I have a master's degree in computer science. I graduated on the field of computational humor. So
interesting.
Having a computer generate jokes. Can that be possible?
Huh.
A spoiler alert, no. But but sometimes stuff that the computer does while trying to generate jokes is actually funny. But not because it's funny by itself. It's funny because the computer tried to do something and it did it so horribly wrong.
Right.
That it turns funny.
That's really interesting. I hadn't considered that. Like, I've looked into algorithmic, like music generation and things like that. I've experimented with that on my own, but I hadn't thought about it for humor. That's fascinating.
It is, isn't it?
So the IOI, kids would be traveling to different parts of the world. Are there like scholarship funds or opportunities to assist with that travel for kids who might not be able to afford it?
So the IOI is based on national delegations.
Okay.
The national delegations fund the travel for their national team. So for 4 students.
Huh.
There are a few countries that don't have enough money, and then they come with fewer people. But so most countries can find the money for 4 kids and 1 or 2 team leaders to get to the international final. And there is a few that can't. And for those, if someone's willing to sponsor, seriously, give me a call, send me an email message, because I know good ways to use that money to give more kids an opportunity.
Are there other questions that I haven't asked about IOI or Bebras that you would like to discuss?
You haven't really asked about the community. So the IOI is a community. All these kids that are there, they're happy for each other. They play together because they're there for a week and there are only 2 competition days. On the other competition days, there are cultural events where you see the host country. So there's the cultural event at IOI where all the kids get together. They go on excursions together, sometimes to an amusement park, sometimes to a film studio like we did last year in Japan. We went to the Eternal Flames this year in Azerbaijan. We were even in Iran a couple of years ago, and we saw loads of cultural stuff there. And the kids hang out together. They play. Some kids are really good at playing the piano or the guitar. They sing and they play little games. And I think that whole community thing where everybody feels at home, you're accepted for who you are, is just a great thing. And it's also one of the goals of IOI. So IOI has as a goal, to find the best kids, but also to have the leaders of tomorrow mingle, meet each other, and figure out that, that person is actually just a person, just like I am.
I really appreciate that you brought up the community aspect of IOI. I definitely think that's an important thing. Do you have any questions for myself or that you'd like to pose for the field for hopefully people to pick up and build off of for the future?
Well, I mean, my main question is I would like to have more people in the US help me out reaching more people in the US. Because it's a little bit insane that here I am in the Netherlands as a volunteer with an American wife and American children, but trying to, bring as many teachers in the US into this field. And we work together with some researchers and with some universities for second rounds, but I'd love to just have second rounds in more states.
Right.
And I'd like to have some of the, I know you're from Arizona, and I've spoken with some people from Arizona once, and they said that when it comes to education, Arizona was in the bottom 10% of the US.
Yeah, generally.
And they were interested in, bringing Bebras out to the rural areas of Arizona. But they said, yeah, the problem is that nobody really wants to sponsor it. The government doesn't, and I don't know if the government doesn't care. Maybe they just don't have the right contacts. But I would love it if we could set something up like Australia does. In Australia, there's a team of 3 women that go rural, and they just go from school to school. And that's what they do. They're on the road for 10 weeks nonstop, where every day they go to another school and they do Bebras on site in that school, where they give extra information to the parents and teachers, some teacher instructions. And I would love it if we could get something like that going, a grassroots movement in the US in a single state first, where we use that to, bring you from the bottom 10% to the top 10%.
So where would you recommend people go to learn more about Bebras and IOI, or to be able to reach out to you to get more information and potentially start?
Well, if you want to know more about Bebras, you just go to www.bebraschallenge.org. So that's where you learn about Bebras, but you don't really learn about me there. If you're in the US and you want to know about more about IOI, I would really suggest you go to usaco.org. So the United States of America Computing Olympiad.org, because they also have the USACO training pages where they will teach you programming, and they'll teach you about algorithms, and they have problems that get more and more difficult and probably a little too slow. I mean, 20 years ago, this was the thing you wanted to go through if you wanted to win IOI. These days, if you go through this, that's your starting level when you can actually start understanding what happens at IOI, because IOI has moved on as well. But it's a great resource. And they have their challenges and the competitions and their different rounds all the time. So that is what I would suggest you go for. And
Excellent.
if people just want to reach out to me, just send me a message at eljakim@gmail.com, and I will, respond as quickly as I can, because this is what I do and this is what my life is.
Is there anything else that I haven't asked that you'd like to talk about?
What's interesting, and I don't know if it's a true motivator. I mean, it's not something I would like the kids to be motivated by, but if you make it to IOI and you win a medal there, and that means you're in the top half, because half the kids at IOI get a medal. If you win a medal at IOI, you're basically guaranteed an internship at Google, Facebook, HP, Microsoft, Instagram, all these big companies, all the tech companies. They love the people that have come to IOI. Now, if that is the type of motivation that you want people to have, I don't know. And I also have a couple of friends that did go to IOI on my team, decided not to go to college and just wanted to work. But, having been to IOI is not only a great experience, it's also just, a career building step. I would like to know more about your music stuff. What did you do for music stuff?
So I'm a percussionist. Both my wife and I play the drums. So my background was in music education. And so I taught general music and band and drumline and all that stuff. And then I started dabbling with some coding stuff that related to music, like creating software music apps, or creating an algorithmic drum set, stuff like that. And just kept going down this path of, well, when is this music, when is this coding, and when is it the two inseparable? And not having an answer to that, I went back into the classroom after I finished school and started teaching K-8 coding classes, 5-year-olds through, what would that be, 12-year-olds, 13-year-olds, how to program. And it was all arts based. So kids were creating animations and art and stories and games and music, and they could pick from all these different subject areas that they wanted to apply coding to. Then that led me to my current position, where I create curriculum and oversee professional development.
Okay, cool.
It's kind of all tied together. I had initially, when I was in high school, I wanted to be a programmer because of the pay. And when I was in the class, the teacher would give us a month worth of assignments. I'd finish it in a week, and then there would be nothing to do for 3 weeks. So I'd be really bored. So I was like, okay, well, music is challenging me a lot and is helping me out. So I went into music education because I just wanted to help people. So although I could have made way more money going into programming, I went into education because of the challenge involved with music, and then came back to programming through education.
Right.
Thank you so much for taking the time to listen to this interview. I really hope you got something out of this. If you'd like to find out more about the Bebras Challenge or IOI, remember to please check the show notes at jaredoleary.com. You will also find all the links that Kim mentioned in it. And just a friendly reminder, if you enjoy this episode, please consider subscribing so you can hear the next one. The next episode that is actually coming out on the same day as this one is me unpacking some scholarship